All right, so we'll go ahead and start with the ungraded assignment over the weekend. I mean, on Monday, not over the weekend. That one we did already. So this one is for conditional statements. We'll go ahead and read what it is about. So assume you're given a variable x that is a number. It can be negative, 0, or positive. Write a conditional statement, a single conditional statement, so that the effect of the statement is to take the absolute value of x and store that absolute value in a variable y. So we have two variables. One is x, which you start with a particular value. The other one is y, where we store the absolute value of x. After the algorithm is written, trace the algorithm with the following test cases. X has an initial value of -4, 0, and 3. So there are 3 test cases in this case. Y, on the other hand, has no specific initial value, so we just put a question mark as the initial value of y. All right, so there are 2 parts to this question. The first part is to figure out the pseudocode, and then the second part is to trace the pseudocode to make sure that it does work for these 3 test cases. Okay, so what we'll do is we'll go ahead and write the code. So now the question is, how do we get started writing pseudocode, or how do we get started figuring out the logic of algorithms? Okay. Now this one is a little bit easier because I told you ahead of time that we need a conditional statement. So you kind of know what it looks like. So we'll start with that. So if a condition, then we do something, else we do something else, and if. So this is the general format of every conditional statement. So we got 3 parts to fill in. We got the condition, we got the then statement, we also get the else statement to figure out. But we also have some other clues. We know that x is already given. So if x has a given value and is the only variable with a given value, I would assume that x needs to be involved here. Does it make sense? That something about x is going to help us make the decision which way to go. So now we really have to kind of think about the meaning of absolute value. So what does it mean when I say I want the absolute value of x? What does it mean? Okay, go ahead.
Magnitude away from 0?
So we want the magnitude from 0, which means what is the absolute value of -20? 20. What is the absolute value of 4? 4. What is the absolute value of 0? 0. Very good. Okay. What if I don't know what absolute value is? And you look it up. You Google it. Very good. Okay, you guys know my favorite professor now, Professor Google. Yes, you just Google it. Okay. All right. So knowing that, do we have anything to do, or do we have much to do if x is already at least 0? So let's say x has a value of 20. Okay, what should y be in that case? Y is just 20. What if x is -10? Y should be the negation of x. Okay. Oh, okay. So wait. So that means we do one of 2 things, right? So either y gets x all by itself, like itself, or y gets the negation of x. Those are the 2 things that can potentially happen. But we cannot do both at the same time. It's always one or the other. Okay, so if that is the case, I'm going to stick 1 here. I'm just going to say y gets, okay, let's put negation of x here. It doesn't really matter because all we have to do is to flip the condition. Then we can reverse the 2 statements. So I'm not even so concerned about the condition right now. I just say in some cases we need y to be the negation of x. In other cases, we need y to be just x without the negation. Is that okay? So now we go back and try to figure out how do we make the decision which way to go. What do you think? We already know the condition here has something to do with x. Yes? If x is less than 0. Exactly. So if x is less than 0, then y gets the negation of x. If x is not less than 0, then y just gets x by itself. That's it. That's the whole algorithm. So now what we do is we give line numbers to this thing, okay? Because you will need line numbers in order to trace, because otherwise there's no way to tell which line you're executing So we need line numbers. If you're using a spreadsheet, you can just use the row number as the line number. But since I'm not doing that, I just have to add the line numbers myself. Okay, so this is my algorithm. Now we need to trace it. So to trace an algorithm, the typical way that I do it is to use a spreadsheet. So we just need to, well, I guess that worked. So I go to my Google Drive, and I will put this file in the shared folder. So after class, you guys can just look at the document, look at the spreadsheet, and you can get everything that we did today. So we go to shared, and I'm going to name the spreadsheet after today's date. So this way it's easy for you to find the document that I create on a particular day. Yep, my computer is slow. There we go. 2018, October 24th. There we go. All right, what is the first line that we need? What is the first column that we always need when we are tracing? Line number, exactly, because we need to know the following is the effect of executing which line. In this case, we also need a column that I will just say comments, because we need to know why we make a decision in a particular way. So we need to comment on the condition that we evaluate. We have two variables. We have x as a variable and y as a variable. So those are the four columns that we need. Typically, you will need a little bit more space for comments, but this time, we don't need that much because we only have a single comparison whether x is less than y, so that doesn't take up much space. And we also need a row that starts with pre. In other words, we are basically asking, what do we know before the algorithm starts? So now we have to think about the three test cases in the description. What was the first one? When x equals to -4. Very good. So -4 here, and then we put a question mark in y. In other words, we don't know exactly what the value is for y, but it's not even important. So we take these two. I typically take these two and make it a little bit narrower, so it's easier to look at. All right, we start on line 1. And then we look at line 1. Okay, let me go back to the code here, and then switch the other one back to the spreadsheet. So this way I can show both the code and also the spreadsheet at the same time. So on line 1, we are not changing anything. All we are doing is to evaluate a condition. A condition is kind of like an expression, except it gives you one of two possible answers, true or false. Okay? So in this case, x has a value of -4. -4 is less than 0 is true. Very good. Okay, so we write that down. Okay, we write exactly that down. We say x is less than y is true. Okay, getting back to the algorithm, where should that bring me? What is the next line that I should execute? Line 2, very good. So on line 2, it has an effect of evaluating the right-hand side. Because x is -4, the negation of -4 is +4. And then what do we do with +4? Well, what do we do with it? We assign it. We use it to update variable y. Very good. So on line 2, we update variable y with a value of 4. And then what do we do? Do we go to line 4? No, because it's a conditional statement. We only follow one branch. When we are at the end of a branch, we get out of the conditional statement, the entire conditional statement. Now, there's nothing after line 5, so we have no code to trace after the conditional statement. So now we just say, there's nothing else to do. When there's nothing else to do in the trace, I use the word post, which stands for post condition, to basically say, this is it. Okay? This is the entire post condition of executing the algorithm in this case. So are we good so far? Yeah? Okay. All right. So, but we have additional test cases. So I'm going to create additional spreadsheets by copying and pasting. So if I copy and paste like this, it actually pastes the width of the columns too, so that's kind of handy. But I have to erase a good portion of what we have done already, and because this time x starts with a value of 0. This is our second test case. Okay, so we go to line 1 again, okay, and we ask the question, what do we do on line 1? Line 1 doesn't change any values of any variable. All it needs to do is to evaluate the condition. Is x less than 0? Well, x is 0 already. 0 is less than 0 is false. Okay, so we write exactly that down. Okay, so we say x is less than 0 is false. So now we go back to the code and go, okay, if the condition is false, where should I go next? What is the next line that actually does something? Yes?
I don't want to sound like a bonehead, but if the two numbers match, then they're either greater than or equal to?
If two numbers are the same, then you can say it's less than or equal to, it's also greater than or equal to, or they're also equal to. But we are not asking that question. We're asking whether they're less than. So 0 is less than 0 is false. It is not the case. If the comparison operator is less than or equal to, then it will be true. Okay, all right. So in this case, the answer is false, which means which line should we go to? Line. Why do we go to line 5? It has to be else, but when you look at the code, where is the branch? What is the code corresponding to the else branch?
Line 4.
Line 4, not line 5. Yep.
So you wouldn't ever write down that a process is happening at 3?
If you write down 3, I'm not going to take any points off. The reason why we don't do this is because line 3 absolutely does not do a single thing. Now, line 1 does, okay? Line 1 is not entirely useless, even though it doesn't change anything. It does evaluate a condition so that we can decide which way to go. So that's why tracing line 1 is significant. But line 3 doesn't do a single thing. All it does is to separate the then branch from the else branch. Because without that word else, we wouldn't be able to tell the difference. But in terms of execution, in terms of runtime behavior, it doesn't really do anything. And so that's why we don't trace it. So that's why the next line we go is line 4. Line 4, okay, we check out line 4. Line 4 says, whatever x is, we'll just update y with that value. X is 0 in this case, so that's why y is also just going to be 0. But after line 4, there's nothing to do, so we get to post again. So we're doing okay so far with the trace up to this point. We good? All right. So the last test case. So once again, I'm selecting all 4 columns. Control C, go to a new spreadsheet, Control V to paste, and then we erase some of the cells that need to be changed. We'll erase all of those. And this time I think it's 3, the last test case. Is that it? Yeah. Okay. So we go back to line 1. And line 1, I remember, okay, is checking whether x is less than 0. And what do you think? It's false. Okay, so that means we go to line 4 again. Whoops. When we are on line 4, we are updating y with just x without the negation. So x, which now has a value of 3, is used to update y. So y also ends up with a value of 3. And then we are done. Post. So that's it. That's including both the pseudocode and also the trace of the 3 test cases. Are there any questions about this particular ungraded assignment?
Is this typical of stuff that's going to be on the exam? Seems a little easy to me.
Well, we start off easy. Yep, we're just going to start off a little bit easy, and then things will get a little bit more complex as we go. Yep.
Will we ever have to declare variables in this class?
certain things we have to declare. So by the time we get to parameters and local variables, then we have to start to declare. But at this point, global variables, we don't do any declaration. Okay, that's a good question. Does everybody understand the significance of that question? Do we need to declare variables? Yep. Go ahead, Izzy.
So when you declare variables, a variable is basically like anything you can name in a program and then reference things under that name.
Okay. But the significance of the declaration of a variable is to announce the existence of the variable.
Oh, yeah.
Yep. So right now we are not having any declaration. In other words, we just say, oh, variable x just magically comes into existence. Variable y just magically comes into existence. There are programming languages out there that do not require the declaration of variables. The moment you start to say z equals to 2, z just magically starts to exist. Okay? Most scripting languages are like that. So that includes PHP, Perl, Python. I'm not sure about Python, so that may not be the case. I know JavaScript is like that. Okay? So most scripting languages do not require declaration of variables unless you turn on strict mode. Then it needs declaration. But the class that you're going to, which is cisp300, in C and C++, declarations are necessary. It is a part of the programming language. But because we're dealing with pseudocode, we're ignoring that for now. Yep?
Just to ask for future reference, with this tracing that you do, because I'm assuming you do both classes, when going into C, is there a separate thing that we have to do as far as like how to trace like each declaration of a variable?
No, there's nothing to trace about declarations, because the declaration is really a communication to the compiler to inform the compiler that these variables will be needed and they have a particular type. So that really just does not affect runtime behavior, because it's really just informing the compiler, oh, by the way, if I use this variable in the wrong way, let me know. Or if I accidentally refer to something that is not declared, let me know. In other words, it really is a feature to have the compiler to check the code for you for potential problems. Okay. All right. So we are done with this part. So now we're going to move on and continue with loops. So we go to Canvas, and then we move on to the discussion of loops, which is the last module that is posted here. I have a lot more modules, just not linked to Canvas yet. All right, so this is the note about loops. The first kind of loop that we talk about is a repeat until loop. So repeat until loop is introduced first because this is how we say things. Okay, you might tell somebody and say something like doing dishes. Okay, repeat doing dishes until all the dishes are clean. Okay, repeat doing blah 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 until a condition is true. Okay, so we use the word repeat and the word until a lot more than while, that sort of thing. So that's why I want to start with this one. Okay. So in this case, this is absolutely pseudocode. Okay, it says repeat, take a bite until that person is not feeling hungry anymore. Okay, that's a loop. So that person will just keep taking bites until the person goes like, well, I don't think I'm hungry anymore. Then you get out of the loop. Huh?
Is this the opposite of do while?
In a way, in two ways. Okay, but let's not talk about do while yet. Okay, so we'll just take a look at this one. So the question is this implying that person should take a bite first before evaluating whether that person is still hungry? It does, okay? But in English, that is kind of vague, okay? So if you tell someone, repeat XYZ until some condition is true, it is kind of vague whether that action should be performed first or whether you should check the condition first. But in programming, we always perform the action first, then we check the condition. So there's an explanation of the syntax, which line is doing what. Okay, so I'll just kind of talk about that a little bit. Line 1, which is just the word repeat, is nothing more than a marker. In other words, all the purpose of the word repeat is just marking the beginning of the body of the loop. What action is supposed to be done in a repetitive fashion. And repeat is kind of like a keyword to say that whatever is after this is part of the thing that you need to do repetitively. So the word repeat doesn't do a single thing other than marking what is the beginning of things that you want to do repetitively. Line 3 is another line that seems like it's just a marker, but it's not. Okay, the word until is kind of like the end of the action that you want to perform in a repetitive fashion. But it's not just a marker because there's a condition after the word until. The condition after the word until is what we call an exit condition. An exit condition, as the name implies, is the condition in order to exit a loop, in order to get out of a loop. Okay? So the until line, which is line 3, needs to be traced, but line 1 does not need to be traced because it doesn't really do anything. Line 2, or whatever is between the word repeat and the word until, is specifying what you need to do in a repetitive fashion. In this particular example, it is just taking a byte. Of course, in a real program, it is not going to be taking a byte. You'll be doing some operation that can potentially change the value of a variable. So do we have any questions about this slide here, the content that is on the projector at this point? No? Okay. Yep, go ahead.
If you have multiple repeat commands,
Mm-hmm.
would that just be separate lines?
That's a good question. It depends on how you organize your loops. Because you can have a loop inside a loop, you can have a loop after a loop, so it all depends on the positioning of your multiple repeat untils. Okay, so we'll get to the concept of nesting loops and conditional statements and whatnot a little bit later. Okay, but that's a good question. Okay, so this is kind of the trace based on that particular code. So line 1 does not need to be traced because it doesn't do anything. Line 2 is taking a byte, so that will be the first byte. And then line 3 checks the condition to see whether that person is still hungry. If the condition is false, which means it is not time to exit the loop yet, we go back to line 1. Well, once again, it is not necessary. So we go to line 2, take another byte, which is now the second byte. Then we go to line 3 again, check the condition. We go back to line 2, take the third byte. And this time, let's assume the third byte is the last byte that this person needs. Okay? So now the person is feeling not hungry anymore or full at this point. So now the condition is true. Okay? The exit condition is now true, and we get out of the loop, and then we continue on to line 4. So this is kind of like an example of going through the pseudocode that we have talked about a little bit earlier. Are there any questions about the tracing of this code here? It doesn't really do a whole lot. I mean, this is not realistic because a program does not eat. Okay? Yep. Question? Yeah.
It says on line 3 the condition is evaluated.
Mm-hmm.
Is that the repeat or the until?
It is the until. Line 3 is the until. And the condition being evaluated is whether that person is feeling full or not. Yep. And you probably know that we cannot do this without a picture. So here's a picture of a repeat until loop. Okay. So take a byte is an action, and you can see how when you're coming from the north. Okay. So you're coming from the north to the south. Okay. This is like a hiking trail. Okay. So this is a hiking trail, but remember, unlike a real hiking trail, all of the hiking trails that we talk about in this class are directional. You can only go in one single direction. So if you follow these directions, then when you're coming in, you cannot just take this path and say, oh, I'm done, let's get out. Nope, because the direction doesn't match. Okay? I know a lot of people get into the parking lot using the wrong direction. Not here. This is strictly enforced. Okay? So you have no choice. Okay? If you get into this loop, there's no choice but to take a byte first. You take a byte, then you get to this junction here. Okay? This is a fork, which means there are two ways to proceed. Anytime you see there are two ways to proceed, you look for a question. You look for a question where the answer to the question is either true or false. In this case, the question is this person feeling full or not? Well, it can either be true or false. If the answer is true, then you get out of the loop. If the answer is false, then you go all the way back to the beginning and take another bite. So that's the structure in the pictorial form of a repeat until loop. Do we have any questions about the construct of a repeat until loop, or the equivalency between the graphical representation as opposed to the pseudocode representation here? Any questions? No questions? All right. So if there are no questions, then we'll talk about why a repeat until loop is not used very often. It has to do with, in this case, what if that person, okay, so let's look at the picture. What if this person is coming in, after a buffet, is already feeling really full? Well, the loop says you have to take a bite first before you answer the question, are you still feeling full? Okay, that doesn't seem to make any sense, right? Yes?
Would that cause the value to be added and then cause the program to be carrying a higher value? Like, let's say the program was to take 3 bites, then it would say that it had 4.
If you do not take it into consideration, yes. So you have to be very careful whether you want that action to be performed regardless. Okay?
Yeah, because if it's not ready to handle that, couldn't that cause a Stack Overflow?
No, this has nothing to do with Stack Overflow.
Okay.
Yep. But you might end up doing something one time too many. Like in this case, if the person coming into this trail is coming off of a buffet, okay, is already full, okay, filled to the brim, as they say, that person has no choice but to take another bite before having a chance to make a decision to proceed. I just want to move on or go back and take another bite. Okay? So I hope a vomitorium is available in this case. Just ask the Romans. They're the expert on this topic. Yep.
Would this be an instance where if it was nested into another conditional statement, like say a person was walking into a room after coming from a buffet, they could read a conditional statement before this loop that asks whether or not they're full?
Well, or you can change it to the next form of a loop. Okay. So we'll now proceed to the next one. All I want to do is to point out this is what I call a post-checking loop. Can someone tell me why it's called a post-checking loop? Yep. Yep. Go ahead.
Sorry. I was going to say what she said, but I just started saying it.
Oh, okay. Okay, so the answer is right. Okay, so both of you are correct. Okay, the word post is after. Okay, so post-checking loop means we check the condition after we perform the operation, not before. Okay, so if this loop is called a post-checking loop, what do you think the next type of loop is going to be called? Okay, pre-checking loop, exactly. So the next form of loop is called a pre-checking loop. And this is a play of the word while. Okay, is it all worthwhile? Because typically when we want to specify a pre-checking loop, we use this kind of wording. Okay, we use the word while. So we say while, and then the condition, whatever action to be done repetitively, and then end while in this case. Now, why don't we say repeat and then end repeat? Does anyone want to kind of give it a try? Go ahead.
It may not be necessary to repeat.
No, not because of that. It's because the word until is a lot of times used in conjunction with repeat. That's just how we use the language naturally. Okay? But while doesn't have anything to match the end of the word while. So that's why we have to artificially introduce the phrase and while to mark the end of a while loop. Repeat until is kind of natural. I mean, a lot of times we use the word repeat and then use the word until, as the delimiters. One serves as an open parenthesis, the other serves as a closed parenthesis. That's just kind of natural to English. But while doesn't have a natural end, so we have to artificially introduce the phrase and while to mark the end of a while loop. All right, so if you look at this loop here, it looks kind of the same as the other one, but something is entirely opposite. There are two things that are entirely opposite. The condition is opposite. Last time we were asking whether one is full. This time it's the negation of that, okay? Because this is actually specifying the while, the condition after while is specifying under what condition should I continue to stay in the loop, okay? And that's why it is the opposite. As long as you're not feeling full and as long as you're still feeling hungry, take another bite. What do I do after taking another bite? Go back, reevaluate the condition. Are you still hungry? Yes. Go take another bite. And then go back and ask the question again. Are you still hungry? No, I think I'm good. Now we exit the loop. Is that okay? All right. So the following is just a simulation of the execution of a loop, which is what I just said verbally. And then the trace looks like this. The trace looks like this if a person comes in from a buffet already. So if that person comes in already feeling full and not hungry, then the condition to stay in the loop is false to begin with. So in that case, we do not even perform taking a bite even once, and we just skip the whole thing and say, okay, let's move on to the next thing that we need to do. Is that part okay? Maybe? Okay, maybe showing the picture would help. So this is the construct of a pre-checking loop. It looks a little bit more complicated, but it really is not. So once again, we come in from the north, okay? We come in here. This junction here has no condition associated with it because it is the merging of two incoming paths. So there's no decision to make. There's only one way to proceed. So once we get to this junction here, then we have a question to ask. Because at this point, there are two outgoing arrows at that particular intersection. So we have to ask a question because the answer will help me decide which way I want to use. What is the question? The question is, one is not full. Is that true or not? Okay? That's always what we're asking, is whether the answer is true or not true, false. If the answer is true, we go ahead and take a bite. But what do we do? Sorry? Oh, I thought I heard a question. So after we take a bite, what do? We go back. Do I have a choice? Not at that moment, okay? So after we take a bite, we follow this path. We go all the way back to this beginning here. And then when we get to this point, then we can make a decision again. Because now we can ask that question again. Am I still feeling hungry? If I'm still feeling hungry, then I go here and take another bite. But if my answer is no, I'm okay now, I'm not feeling hungry anymore, then we take this exit path and continue on with whatever is after the loop. So is that okay? Is that picture, are you guys understanding how the picture is corresponding to the pseudocode? All right, excellent. All right, so most of the time, okay, we do not use a post-checking loop. In other words, repeat until is used very, very rarely. Okay, a while loop is used a lot more. The pre-checking loop concept is used a lot more. With what kind of ratio? Okay, how many times, what kind of percentage are we talking about? Now, in my own personal programming experience, I would say it's at least 95 to 5%. So 95% of the time, I use a pre-checking loop, and only about 5% of the time, it feels natural to use a post-checking loop. Yes?
Is there a simple example you can give us of when a post-checking loop would actually be useful?
Right here. So one of the very few examples is when the condition that you need to check is the result of the action that you're performing repetitively. Then it makes sense. Okay, so let's say you're designing a program and it's interactive, you're asking a user for a zip code, okay? And you have some way to check whether a zip code is valid or not. Is that making any sense? Okay? You cannot use a pre-checking loop because if you turn this into a pre-checking loop and say, while zip code is not valid, keep asking, ask for another zip code, then what are you checking the first time? Nothing. We don't have any user input yet, right? So in that particular scenario, it makes much more sense to use a repeat until loop or post-checking loop, because the action that you're performing, which is asking the user to enter a zip code, gives you the very value that you need to use to check whether I should ask for another zip code or not. Is that okay? So it doesn't happen very often. Okay, this happens very, very rarely. So most of the time, in my own programming experience, is at least 95% of the time we use pre-checking loops. Very rarely do we need to consider a post-checking loop. Is that okay? All right. Okay. So the code, the modules is pretty much done at this point. I can always attach additional modules, during class. Okay. But what we want to do now is to actually go through some examples of making use of loops with numbers. Okay. So I'm going to throw a few examples out there, and then we'll go ahead and trace these examples. So what I'll do is I'm going to use my spreadsheet. I'm just thinking about how to go about doing this. I need to think about how to do this because before, like the last time I taught this class, I wasn't using Google Spreadsheet. I was using LibreOffice. So the interface is a little bit different, and I can organize things in a slightly different way. So this is the first time I use Google Spreadsheet for this kind of purpose. So it's going to be a little bit different. So let me go to my Google Drive. And let me go to my spreadsheet for today first. Okay, there we go. And I will specify the code in the spreadsheet too, but the problem is I have to display both the code and the trace at the same time. So that becomes the big challenge of how do I organize my screen area for that purpose. Yeah, my computer is really slow. So maybe this is not the best way to do it. All right, fine. We'll use the built-in spreadsheet using LibreOffice Calc. We'll see how this should be a lot faster. There we go. It is a lot faster. Okay, so we'll use this method until I figure out how to do the other way faster. All right. So what we'll do is we'll specify a few examples. We'll trace through those examples, and then also notice important points as we go through that. So in this case, let's say we start with a local variable x, or we start with a variable x. Let's not even consider whether it's local or not. X starts with a value of 0, and then we specify while. Can you guys read it all the way to the back? Is it too small? Too small? Okay. Let me magnify it a little bit.
X equals 0?
Yeah. It's a left arrow, which is the way that I specify assignment in pseudocode. So we say as long as x, or while x is less than 3, okay, we increment x. So incrementing x is x gets x plus 1. This is annoying because it's doing the capitalization for me. So let me go ahead and change that option. It's where do I change that? Autocorrect. There you go. So I have to turn off autocorrect except for certain things. Okay, there we go. Use replacement table is fine, but do not auto-capitalize. There we go. And that should be fine for now. Okay, let me go back and retype this because I want to use lowercase x, not uppercase x. The reason why I try to use lowercase x is because in programming, the convention is your variable names should start with lowercase and not uppercase. What if I decide to use uppercase, as the first letter of a variable? What's going to happen? Well, the compiler is not going to complain. Your program will still work fine as long as you use that name consistently. But what's going to happen is your peers, your coworkers, and your boss will frown at you because that is not the convention. Is that okay? All right. And then we have end while here. This needs to be indented. So let me look for the indentation icon. I haven't used this for a long, long time. There we go. And then we have line numbers.
Is this x equal to 0?
Huh?
First one should be the same.
Oh, x gets x. Yep, x gets 0. Because otherwise, it has no value to add 1 to. Okay, good point. Okay, and then we resize the columns a little bit. And then we add a new sheet for the trace. Now, this is the cool thing that you can do with LibreOffice. I suspect you can do the same thing with Microsoft Office as well, is you can open a new window. So I can go to Window and say New Window. So now I can resize these two accordingly. Okay, so I can make it resizable for this one and have it displayed on the side of the first one. There we go. And once again, the text size has to be increased a little bit. I will do that in just a little bit. There we go. And this is going to be sheet 2, and that's where the trace is. So the trace is going to be starting with a line number. And we also need comments because we have to evaluate the conditions. We only have one single variable in this case, which is x. The precondition is I don't really need to know what x starts off with because the first thing we're going to do is to initialize and overwrite it. So x does not need to start with any particular value, and that's why the precondition of x is unknown. Okay? It has some value, but I don't know what it is. Are we doing okay so far with this part? Okay, so we get to line 1. Line 1 definitely has something to do because now x has a value of 0 because it's the initialization of the variable called x. Then we go to line 2. Line 2 has something to do too because we have to evaluate x is less than 3. Is that true or not? Yeah, it's true. Then we go to line 3. Line 3 has a very simple thing to do. We evaluate the right-hand side. 0 plus 1 is 1. And then we use that to update x itself. So x is now incremented to 1. Okay? And then where do we go? We go back to line 2. Okay, so that's very important because a conditional statement does not go back. A if-then-else statement keeps going forward. It doesn't go back to an earlier place. A loop, on the other hand, does that. So now we go back to line 2. What do we do on line 2? Re-evaluate the condition. So we are re-evaluating x is less than 3, but we are using the current value of x. The current value of x is 1. 1 is less than 3. Well, it is still true. But we are using the current value of 1 instead of 0. We go back to line 3, and line 3 is going to add 1 to x. X goes from 1 to 2. Then we go back to line 2 again. We re-evaluate the condition. It is still true. We go to line 3 again. We add 1 to x. X is now 3. And then we go back to line 2. We re-evaluate the condition. X is now 3. 3 is less than 3 is false. Do we have anything after line 4? Nope. So that means we go straight to post. There's nothing else to do now. Is that okay? So you look at this and go like, we only performed 3 times in the iteration, but I can see that x has 4 entries, 0, 1, 2, and 3. Why is that the case? Yep.
The loop recurred itself, and it increased by 1 every single time. So
Yep.
multiple times.
Yep. The first one is the initialization. The 0 is the initialization. Yep. Very good. So let's go ahead and see what happens when, so what I'll do is I'm going to save this file and then make a copy of that. So we'll go ahead and save this file. And let me make a new folder. We'll call that cisp310. Oh, 300, but that's okay. 2018, 1024. Okay. And now we'll save it again, save as, because I want to change the program just a little bit. So I'm going to make the next one A. Okay. So when I make changes, I'm going to have to erase most of the trace itself because the algorithm is going to change. So the one change that I'm going to make to this program is let's not initialize it to 0. Let's initialize it to 200. Okay? And we want to find out what's going to happen if x starts up with a value that is already greater than or equal to 3. Okay? All right. So does anyone want to tell me what happens to line 1? I mean, that's the easy one. Yep. X is initialized to a value of 200. Okay, very good. And then we go to line 2. Okay, line 2 is evaluating that condition. X is less than 3 is false. Quite obvious, right? And what do we do when the condition is false when you have a while loop? We get out. Okay, we get out of the loop. There's nothing else to do, and here's post. So line 3 does not even have one chance to execute in this case because it is a pre-checking loop. We check the condition first. If the condition is false to begin with, we don't even perform one single iteration. Is that okay? All right. So now let's go ahead and take a look at the repeat until loop, okay, the post-checking loop. Because I want to compare and contrast between those two. So now we change this and say, let's say x start with 0 again, but this time it's a repeat until loop. So x gets x plus 1 until x is less than 3, until x is greater than or equal to 3. Okay, because we have to specify the exit condition instead of the condition to stay in the loop when we use repeat until. All right, so indentation. Where's my indentation tool? There we go. All right. So this is now the code that we want to trace. And then sheet 4 is going to be the trace itself. So here's the code, and here's the trace. Kind of the same deal. We have line number, we have comments, we have x as my variable. Same thing here. We have the precondition saying we don't know anything about the initial value of x. And then same thing here. We start with line 1. And line 1 still does exactly the same thing. X is starting with a value of 0. Then what is the next line I should execute? Or the next line I should trace? Line 3. Very good. Because we don't trace line 2. Line 2 doesn't do a single thing. Line 3 is the one that does something. What does it do? We add 1 to x. X goes from 0 to 1. And then we go to line 4. Line 4 has one thing to do. It has to evaluate the condition. X is greater than or equal to 3. It is false. So what do we do next? Go back to line 3. Very good. So we go back to line 3. X is now incremented from 1 to 2. Then we go to line 4 again. We check the condition. It is still false. We go back to line 3. This time x becomes 3. We go to line 4. X is greater than or equal to 3 finally is true. Then we are done. We get to post. Is that okay? All right. What if I do something just like last time? We change the way we initialize the value of x. Okay. So this time, okay, I'm just going to do the copy and paste again. So copy and paste. I'm using the row number as the line number now, in case you haven't noticed. Okay. So I'm going to use sheet number 6 as the trace, sheet number 5 as the pseudocode that I'm tracing. And I'm going to make some changes here, okay, just like last time. We start with 200. And now we go back to the trace, and we try to figure out what's going to happen with this program. Comments, x. Okay, it starts with an unknown initial value. This is my precondition. This is line 1. X is initialized to 200. Which line do we go first? 3. Line 3. Oh, wait, but x is already greater than or equal to 3. Why are we going to line 2? Line 3, excuse me. Because that's the way a post-checking loop is set up. Okay? So now we're going to line 3. X becomes 201. And then we go to line 4. Line 4 evaluates the condition. X is greater than or equal to 3 is false. We exit the loop. Here's post. But see how this time x ends up with a value of 201 and not 200. Because we don't have a choice. We have to perform that operation on line 3 because the question is asked after line 3. So this is the main difference between a pre-checking loop as opposed to a post-checking loop. Yep?
Is line 4, I just want to clarify, the comment x is greater than or equal to 3, is it false?
Oh, it is true. It is. Nope. Yep, you're right. I used the wrong polarity here. It is true because this time we're looking for the exit condition. When the exit condition is true, we get out of the loop. Thank you. Good catch. So do we have any questions about this part? Yep.
The until
Mhm.
It's always false until it becomes true, and then we exit.
Yep, because that's how we use that word in conversations too. So certain people, when they go to they go to supermarket, they want some place that is really close to the entrance. So they basically execute the loop of repeat, go to the next spot until you find an empty spot. Okay. So we use the pair of words repeat until pretty naturally. Can someone name another phrase that can replace while, but it has the same meaning as while in this particular programming sense? For. Okay, for kind of can do it, but for is not really exactly a commonly used word, in that context. Hmm? Do doesn't specify, a condition. It does not. It doesn't imply there is a condition associated with the repetitive action. Yep. Until is already used in repeat, so we don't want to use that. Yep.
As.
You're close. As long as. Okay. So the word while. So the word while is really saying as long as. Okay. As long as the condition, blah, 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 perform the following action again and again and again. Okay, so if you want to kind of remind yourself what it means to use a while loop, it really means as long as. All right? So do we have any questions about all of this stuff here? So far we have talked about the assignment statements. We have talked about what a variable is. We have talked about what a conditional statement is, what a condition is. We talked about logical operators. We talked about comparison operators. We talked about loops in today's class. So are there any questions about those particular constructs? We are actually done with what we call control structures. Control structures consist of conditional statements, pre-checking loops, and post-checking loops. Now, in a real programming language like C and C++, there are some additional stuff like a switch statement, a for statement, and stuff like that. But those are, for the most part, shorthands of complicated statements that we can express using just these 3 constructs. Okay. So now the question is, how can we write complicated logic using only these 3 rather simple control structures? It's kind of like asking, you only have a concept of folders to organize files in a system, in a computer, right? So how do we manage, hundreds of thousands of files using that one single concept of a folder can contain files, but a folder can also contain folders. Yep. You can put a loop inside a loop. You can put a conditional statement inside a loop. You can put a loop inside the conditional statement. You can put a loop inside a loop, inside a loop, inside a conditional statement, inside another loop, inside another conditional statement. There's no limit of how you can contain one construct within another construct. Okay? That's called nested, okay? Nesting control structures. So that's what we'll be talking about after a short break. So we'll take a 5-minute break, and then when we come back, you will find new modules, in Canvas, because that's what I'll be doing, is to link my modules in so that we'll have those concepts available. I'm going to turn off the